Okay? It says, just as a side note, in many states, drivers under the age of 21 can lose their licenses for driving at that level. Okay? Sorry. All right. So, where does the 7 go? Okay, so let's look at our formula over here. X is the blood alcohol concentration, and R, given as a percent, is the risk of having a car accident. So it's just a 7. It's not written as a decimal. It's written as a percent. So it's just 7 is equal to E, 6 times E to the 12.77X. Okay? Normally, if I have a percent, I do have to put it in as a 0.0 unless they've given me the formula written that way. And it'll tell you. Okay? Are we good? Now, this becomes just one of those problems that we learned last time how to solve. How do we solve this? Get the E by itself, so what do we do first? Divide by the 6. So we got 7 over 6 is equal to E to the 12.77 times X. Now what do I do? Take the ln of both sides. So we got the ln of 7 over 6 is equal to the ln of E to the 12.77X. Now what do I have? That's right. These two cancel out, and I just have 12.77 times X is equal to the ln of 7 over 6, which is just a number, right? And then what do? Divide by that 12.77. Did Alexis go to sleep? Yes. They've been very quiet. Which is what? .012. Okay, that .01 that I was talking about. They pull you over and your alcohol level is a .01. They will haul you to jail. That kind of business, blood alcohol concentration has several factors to it, DJ. You really can't just say it's just one beer. It depends on the person's metabolism. It depends on how much you've had to eat. It depends on your body size. It depends on how fast you drank the alcohol. Like if you drank one drink over a period of 2 hours and didn't drink anything else, then your body will metabolize that alcohol and it won't still be in your bloodstream and it will be flushed out of your system. It's when you drink lots of drinks very quickly, or if you're a very small person like someone my size, if I drank, I couldn't get away with drinking hardly anything before I got into a vehicle because I just don't have a big enough body. I don't know why it's got something to do with your body size, but we do know that people's bodies metabolize the alcohol better if they're larger. Not heavy, but just, more bone, more muscle. It's like I guess it's because of the muscle, your body metabolizes stuff faster if you got more muscle. We know that. All right. Good thing is I don't have to worry about it, right? I don't drink. All right. Checkpoint 10, you're right. How long to the nearest tenth of a year, everybody hear that, to the 10th of a year, one place past the decimal, will it take $1,000 to grow to $3,600 at 8% annual interest if it's compounded quarterly? First of all, it says compounded quarterly. So what did my formula look like? Okay, there's my formula. Now we got to look back at our problem and see what did they give me. What is the 1,000? Nope. The P. What is the 3,600? That's the A. That's how much is going to be in the account at this time when I'm talking about. It's 8% annual interest, so that goes 0.08 in for R, and it's compounded quarterly, so what's in? 4. And we're looking for the time, so that needs to have a variable left in it. So now how am I going to solve this? Can't distribute. Going to divide by that 1,000. So I've got 3.6 is equal to you may see something else that I can do to make my life a little easier. What? Subtract 1. Can't subtract 1. It's inside the parentheses, which being raised to the 4t power. I can figure what this is, right? So that's 1 point, and that's 0.02. Right? Now I got to do what? Anytime that my variable's in my exponent, I take the ln of both sides. So I'm going to do the ln of 3.6 is equal to the ln of 1.02 to the 4t. Now I'm using one of those properties that we learned in Section 3. What am I going to do? Bring the 4t to the front. So I've got the ln of 3.6 is equal to 4t times the ln of 1.02. Now what do I, if I'm going to solve it for t, what do I do? Everything's times t, so how do I get rid of it all? Divide by that stuff. So I'm going to divide by the 4 and the ln of 1.02. Yeah. What? So I just took this 4t right here and brought it down in front because that's my property that says if I'm taking the log of an argument and the argument's raised to an exponent, I can take the exponent down as a coefficient. Whatever that is. 16.17 years. And it wanted it to the nearest tenth of a year, so it's 16.2. So just a little bit more than 16 years. Yep, years. T is in years, remember, my formula? Yep, you need to know that. Okay, and then of course we'll do an application problem with the log, so checkpoint 11. It's using the function that f of x is equal to 54.8 minus 12.3 times the ln of x, where f of x is the percentage of Americans who say that they're in fair or poor health, and X is their annual income in thousands of dollars. So if it was 1, then it's 1,000. Everybody understand when it says that? So it says the annual income in thousands of dollars. Okay? All right. So it says, according to this function, what annual income corresponds to 25% of Americans saying that they're in fair to poor health? So where does that go? And it is a percentage. It's giving it to you as a percentage. Goes with the f of x. So I'm going to put 25 is equal to 54.8 minus 12.3 times the ln of x. And then once you figure out where to put the thing, then you just start doing our process for solving a log problem. Go subtract the 54.8. Anybody done that yet? 18.2, negative 18.2. Jeez, I'm good. Alright. And then go divide by the negative 12.3. So we are back to a positive number. The ln of x is equal to whatever that is. It's more than 2. 2.42. And then how do I solve this when it's an ln? You use e. So the base, which is e, raised to the answer, is equal to the argument. Y'all got to learn how to use that formula. The base of ln is e. E to the answer of the log problem is equal to the argument. No, that's just a number. You just plug that in. 11.0. So 11,000. $11,200. So about $11,200 is their annual income. Oh, we're out. You have to use my paper towels over there. Sorry, I'm out. They're like a sad thing. Yep. Not good, period. All right. So page 467, you're going to do 50 through 90 evens. And then the application problems I want you to do are 102 and 116. Huh? I've already given it to you? Good. Just couldn't remember if I had or not.